Lesson 7.1. And now we're going to focus on multiplying and dividing radicals. And first of all, let's remember we're not going to do this one. So let's cross that out. But we are going to start with D. And in multiplying radicals, we would multiply numbers on the outside of a radical and then multiply numbers on the inside of a radical. In this case, we only have numbers on the inside of a radical. So if you multiply them together, we get 108. And if we simplify this down to prime factors, we have 2 and 54, and then 9 times 6, and then 9 would be 3 and 3, and 6 would be 3 and 2. So we have a pair of 2 right here, and we have a pair of 2's there, and what's left is the root 3. So the 2 comes out because there's a pair of them, the 3 comes out because there's a pair of them, and we're left with a root 3, so 6 root 3. Okay, now we're going to go to division of radicals. Now, just as we talked about, when we have a root of a number, we can separate them into the root of two products and separate into two smaller products, just as we did right here. I could go backwards here and go this direction and separate them. The same goes for division. So if possible, one should write this as 4 and then have a root of the fraction 27/48 and see if that fraction can be simplified, which it can. We'll get 9 over 16. So if we write this as 4 and then go back to separate roots, we'll notice that root 9 is possible and root 16 is possible, which is 12/4, which again simplifies down to 3. Alright, so let's take a look at another division problem and see how this is handled. Now notice we have a number that's not in a root in the bottom. Well, we'll handle it the same way. And if we take this and write it as, we'll go 1 over 2, and then we'll do the big radical, 24 over 3, and that does reduce. 3 goes into 3 once, 3 goes into 24 8 times, so this ends up being root of 8 over 2. Now I cannot simplify the 8 and 2 because one's in a root and one's not, so they are not compatible. But I can simplify root 8, so if I go over here and go root 8, which is 2 times 4, which is 2 and 2, there's a pair, so we'll have a 2 on the outside, a 2 left on the inside, and a 2 on the bottom still. So now we have a 2 on the outside of a root, which now is compatible with the 2 in the denominator, which ends up being just root 2. So let's take a look at what happens if one of those denominators do not fully lose its radical. So this one, again, we try and simplify, and we notice that they're both even, so I can go 12 and 40. They're still both even, So I can go 6 and 20. They're still both even. So 3 and 10. Now we cannot leave this the way it is, because if I wrote it as two separate roots, it'd be 3 over root 3 over root 10. And that's considered unsimplified. So we're going to do what's called rationalizing the denominator, which means if root 10 is the problem, we multiply the bottom and the top by root 10. And what happens is, on the top, again, we multiply these radicals and we get root 30. We did that already. On the bottom, root 10 times root 10 is root 100, which is just 10. And that's the point of multiplying it by itself. On the top, we have root 30, which is not simplifiable, and that's our finished answer. Again, 10 and 30 are you cannot simplify those because one's in the root and one is not. So since we just talked about that, let's see how we can handle this heading, which is what we just did, and realize it's not that much different. We talked about this already. So we would take the bottom times root 2, because that's, you cannot have a root or in the denominator, and I say root and radical to mean the same thing, so I'm sorry if I go back and forth. But this gives you root 2 over, again, root 4, which can be simplified down to just 2. And that's finished. Next one. Root 3 is the problem. So we multiply top and bottom by root 3, and you have to multiply top and bottom, otherwise they are not equivalent fractions. So we have 5 root 3 over root 9, which is just 3. And that's simplified. Again, looking at different scenarios, root 5 is the problem. You can have a root on top of a fraction, but not in the bottom. So again, remember, roots get multiplied by roots. Numbers on the outside get multiplied by numbers on the outside. So there's a 1 here, so 3 times 1 is 3. And the roots get multiplied. We get 10. On the bottom, you get root 25, which is just 5. Now in our last one here, if we remember how we handled this before, root 6 and root 3 can be simplified down to 3 goes to 3 once, 3 goes to 6 twice. So this is the same as 2 root 2 over 3, because you have the root of 1, which is just 1. So this is equal to root 2 over root 1, and again, root 1 is just 1. So this would be our final answer for that one. And this ends the video on multiplying and dividing radicals.